So this video is on the classwork 8-53 to 56. We only got through 53 and then we submitted. Okay, and we got whatever we got through is what we submitted. I'm going to discuss some of the problems beyond just for knowledge. But again, once we got through 8-53, we did submit. And there's a resource page we're going to also use on this, which is also on Canvas. Okay, there's a link here, but if you want to open it so you can use the Cami, you want to get to it from Canvas, it should be right below this assignment on Canvas in our module. So on this, what we're doing is we have a little switch from what we were doing yesterday. Our homework is going to be what we were doing yesterday, but in this case, what we're looking at is a situation where we're enlarging shapes. So it says Mighty Mascot on 8-53. To celebrate the victory of our school's championship girls ice hockey team, the student body decides to hang a giant flag with your school's mascot on the gym wall. So here's the big one and here's the small one. To help design the flag, your friend Archie creates a scale version of the flag measuring 1 foot wide and 1.5 feet tall. So this is Archie's version. This is what it needs to be. So I'm just going to zoom in here. And I'm just going to write down some of the information. Okay. So again, this distance from here to here is 1 foot. And this distance from here to here is 1.5 feet. Okay, so that's his. Now on part A, it says the student body thinks that the final flag should be 3 feet tall. Okay, and again, his version was 1.5 feet tall. We want to figure out how wide this enlarged figure should be and justify our answer. So in terms of this, if I'm looking at this, I don't know what this is. And I'm going to call this X. I know that this distance here, from here to here, the length of this is going to be 3 feet. So right now you can pause the video and see if you can figure out what that X should be. And that is the answer you're going to write for A. Then come back and I will state the answer. So you want to pause and try. Okay, so the answer that you should have gotten should have been 2, because these are similar shapes. Okay, meaning they're the same shape, but different sizes. So what am I doing to this 1.5 to get the 3? Okay, well, I am multiplying by 2. That's what I'm doing. So that means my scale factor is 2. So every time I do it to one side, I got to do it to the other side. So if I multiply this by 2 and I get 3, because I'm doubling it, I also need to multiply this by 2. So when I double this, I get 2. So again, this X is going to be 2, because I'm going to times my 1 foot by 2 and I get 2 feet. Okay. So here, when they're asking us to answer this, the width is going to equal 2. The enlarged shape has a, well, I should say this, is 2 times taller than Archie's. So our scale factor is going to equal 2. So I'm going to take the width, which is 1, and we're going to multiply it by 2, and we're going to get a new width of 2. And again, because these are similar shapes. So whatever I do to one side, I do to all the sides. Now, the next thing we did was we answered B. So it says if Archie uses $2 worth of materials to create his scale model, how much will the materials cost for the full size flag? Discuss this with your team, explain your reasoning. Okay, so we were doing this individually. And so if Archie's cost $2 to make for the material, we want to know how much will the new enlarged one be. So pause, give your answers. So I am not going to say what the answer is yet. What we're going to do, and this is what we did in class, is we used a resource page. It's this resource page right here, but I'm not going to click on it here so I can write on it. Okay. So I'm going to go to Canvas. Okay. And on Canvas, it is this resource page here. Okay, this is not something we're going to submit. We're going to just click on it. And when you open it, you should get this. Okay. Now, this is right here. Let me just highlight for a second. This one here is Archie's. This one here is the one that we're going to be making to hang up, because you see it's got 2 feet. And so what they want us to see, and what they wanted us to do, is to cut these out, the small ones, and see how many small ones make the big one. Now, we're not going to do that. I'm not going to make you print this out. So what we did in class is we came here and we traced one of the small ones. And I'm going to zoom in and trace that. Okay, I traced one of these small ones. Now, once I traced it, what I did is I came here to select, and I'm coming down to this one here that says select annotations. And then I'm going to highlight, or, this. And right now I don't see anything. I'm going to do it again. Now I have copy and paste. So I'm going to copy it and paste. So I have different versions of these. So let me just paste a couple of more here. Okay, I'm just clicking paste, and now I've got those. And so you can keep doing this and get as many as you need. And what I want you to do is then take these and move these. Okay, I'm still using this select annotation, and move this and come and place them here and see how many it takes. Now, unfortunately, you cannot flip these. So fill in all the ones that you can that are this direction, and the gaps that you have will probably be a triangular shape, and assume that that would be the same size, just flipped. Unfortunately, we can't flip something that we draw on Canvas. So pause, try this, and come back and say how many it was. Okay, so I am going to move these. And again, I cannot flip these, but you'll see that the space right here is actually another triangle. Okay, so that would have been the one I would have flipped, but I can't flip. So if I count, I have 1, I have 1, 2, 3, 4 of these. So what that means is if each of these is $2, $2, $2, $2. And it took 4 of them. A lot of students in class said that it was going to be $4 because it was 2 for 1 and the new one's gonna be twice as big. So they doubled that cost and got 4. But it's not going to be $4. It is $2 times 4. And so it's going to cost $8. So that's what we should have had on this question B. So again, a lot of students answered $4. I had a couple who answered 8. But what it was is it's $2 times 4 of the flags, because that's how many will make that big one. And it's going to be $8. Now, what I want you to realize is when we're talking about this $2, how much it costs for the material. When I'm talking about the material, I'm really thinking about area. So the area of the original one is not 2 times bigger when I double the sides. It's actually 4 times bigger. Okay, so when my sides are twice as big, my area is not twice as big, it's 4 times bigger. So here on C, that was what we were doing. And here where you would make your correction if you go, oh no, I thought it was 4, but now I see it's 8. So then on part D, what they wanted us to do is then figure out if it's 3 times larger and 4 times larger, okay? And so if we go back to that resource page, okay, and this is where it's gonna be a little tricky. On the next page, okay, so these were here twice in case you needed more of them. But here is the enlarged ones, and you'll see that this one here is 3 feet going across. Okay, so this one here is 3 feet. And this one here is 4 feet. Okay. And so what we're going to do is we're going to take those shapes that we were doing, the original ones that Archie are Archie's. Now I'm going to come here and I'm going to hit select. Now I'm going to hit copy, so it copies again. And I want to keep this up here because I can't drag them to another page, unfortunately. Yeah, I wish we could, but we can't. So I'm going to scroll, keeping the copy and paste still up here to the second page. And I'm going to hit paste. And now it's on that page. And then I can keep pasting and get others. So what I want you to do right now is see how many of these will fit into this 3-foot one and how many will fit into the 4-foot. Now, again, these cannot be flipped. So what I might do is I'm going to start, obviously that can't go there. So I'm going to put it down until I get it to fit. And you see you have one triangle here and you're going to have a triangle on either side. So take these and move them here, and then you're going to do the same here. And again, you can just keep pasting as many as you want. So do that and then figure out how many it takes. Okay, if you want to pause. Okay, so if I'm doing this, hold on. And I'm getting these in, let me just kind of zoom in a little. So here, what happened is I ended up with one, let me just write a little bigger. 1, 2, 3, 4, 5, 6, 7, 8, 9. 9 triangles. So what does that mean for the price of this? Each of those 9 triangles is $2. Okay, it's really the area, the material for the area of the original one. If I make all the sides 3 times bigger, it doesn't cost me 3 times more, it costs me 9 times more. And so it's going to cost me $18. Now, when I'm doing that for this one, and I'm putting these here, okay, so I've got those. Okay, got another row. So, oops, mine kind of got adjusted here, huh? Okay, so I moved mine slightly. Okay, so on this, how many am I going to get here? I have 1, 2, 3. Let me do this. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16. I have 16. So when each of these is $2 and I made all the sides 4 times bigger, I did not times this by 4, I times it by 16, and it's going to cost $32. So what have we learned? So again, here, what's happening is if each of my sides is 3 times bigger, then I take my area. So this is the sides, okay? My sides are 3 times bigger or 4 times bigger. My area is not 3 times bigger, it is 9 times bigger. Now, in this case, that meant it was $2 for the material times 9, which is $18. Again, if my sides were all 4 times bigger, my area is not 4 times bigger, it is 16 times bigger. So it would have been $2 times 16 or $32. So what's happening here is, how am I getting this 9 and the 16? How did I get this 4? So if this was 2 times bigger, so when it was twice as big, the area was not twice as big. The area was 2 squared or 4 times larger. And over here for this one, I'm just gonna jot this down here. When it was 3 times, and again, this is my sides. When my sides are 3 times bigger, that led to my area not being 3 times bigger, but my area was 3 squared times bigger, or 9 times bigger. So it's my area times 9. And if my sides are 4 times bigger, my area is 4 squared times bigger, or 16 times bigger. So whatever I do to the sides in a similar shape, I have to do to all of the sides. But if I'm doubling or tripling or quadrupling or timesing by 5, the area is not that number times bigger, it's that number squared times bigger. So this is what we got through and this is what we submitted. Okay, now I'm just going to talk about some of the problems on the next page as a reference for you guys who might be out. But again, we just did up through 53. So on 54, write down any observations or patterns you found while working on problem 8-53. For example, if the area of one shape is 10 times larger than the area of a similar shape, what is the ratio of the corresponding sides? So if the area is 100 times bigger, and again, we're talking about area here, not the sides. The sides, because 100 is 10 squared, the sides are 10 times bigger. Okay, we're going backwards this time. Instead of starting with the sides and finding the area, we're going the opposite direction. On 55, use your observations and patterns from previous problems to answer the following questions. Kelly's shape at the right has an area of 17 millimeters squared. If she enlarges the shape with a linear scale factor of 5, what is the area of the enlarged? So if my scale factor is 5, what am I doing to the area? So I'm going to take the area, which is 17, and I'm not going to multiply it by 5, but I'm going to multiply it by 5 squared. And so 17 times 25 is going to be 425. So again, whatever your scale factor is, you're going to take that number, square it, and that's how many times bigger or maybe smaller, depending on how we're going, the area is for your new figure. On B, we have two similar shapes again. What is the linear factor? What is the area of the smaller figure? Okay, so we're going the opposite direction this time in terms of not big to small to big, but big to small. So if you're noticing the sides, what am I doing to 10 to get 40? I'm going basically not from 10 to 40, but from 40 to 10. I am dividing by 4. Okay, or I am multiplying by 1/4. It's 1/4 as big. So what that means is when I'm dealing with the area, my area is not going to be 1/4. It's going to be 1/4 squared or 1/16 of it. So I'm going to take 656 times 1/16. 656 times 1/16. And I get 41. So the area of this one is 41 units squared, whatever the units were. It just says units. While ordering a carpet for a rectangular office, Trin was told by the salesperson that let me just get a rectangle here. Okay, that a 16 by 24 piece is going to cost $800. Okay, so the area is not this, but it's going to cost $800. Trin then realizes that he read the measurements wrong and that his office is actually smaller than that. Okay, it's half of that. Okay, pretend that's half. So in this case, this is an 8 and this is a 12. And so what he's saying is, oh, that's no problem. Oh, actually, this is a salesperson. That's no problem. That is half the size and will cost $400 instead. Is that fair? So they're saying that's going to cost $400 because it's half the size. Now the sides are half as big. So my scale factor, what am I doing from this to this, for example? I am multiplying it by a half or a 0.5. But is that what I should do for my area? So for my area, which is not 800, but it's $800 for the material, and that material would be our area. It's not going to be half as much. It's going to actually be 1/2 squared or 1/4 as much. So if the cost is $800 and the shape, the rectangle shape is half the size, the area is not half, the area is 1/4. So it should only cost $200, not $400. If the side length of a hexagon triples, what does the area, how does the area increase? So instead of finding the area of these, if this is 10 and this is 30, my scale factor is 3. Well, that's true for my sides, but what's true for my area? So I would take my area and I would multiply it not by 3, but by 3 squared. So my area is going to be multiplying by 9. So this is going to be 9 times bigger. Now they asked us to confirm this and calculate it and find the areas. But again, we didn't get through this problem. But if I found the area of this one and I found the area of this one, you're going to see that the second one is 9 times bigger than the first. So hopefully this helps you out.